Betelgeuse, an enormous red supergiant star situated in the Orion constellation, has intrigued humanity for many centuries with its rich crimson glow and colossal dimensions. Astronomers estimate that if Betelgeuse were to be placed at the center of our solar system, it would consume every planet up to Jupiter. This star is so massive that it symbolizes the final phase of evolution for stars like it, poised to culminate in a spectacular explosion, a supernova. In recent years, Betelgeuse has started to show strange behavior. In a surprising twist, its brightness surged by over 50%, pushing it from the 10th brightest star to the 7th in the night sky. This sudden increase in luminosity left scientists scrambling to find an explanation. Was this the beginning of its catastrophic end, or merely a temporary anomaly in its life cycle? The consequences of Betelgeuse undergoing a supernova would be enormous. It could transform the night into day, offering unmatched opportunities for scientific discovery. A star's luminosity is influenced by factors such as size, temperature, and its distance from Earth. Betelgeuse, which has a radius more than 700 times that of our Sun, is relatively cool, with surface temperatures ranging between 3,000 and 3,500 Kelvin. This coolness gives it its distinctive red color. Despite its immense size, Betelgeuse's cooler temperature makes it a prime candidate for a supernova, which is why its recent behavior has captured such keen interest. In late 2019, Betelgeuse astonished astronomers once more by dimming to just 40% of its usual brightness. This phenomenon, visible even to the naked eye, sparked a wave of observation and debate. Some speculated that the dimming was caused by dust blocking the star's light, while others believed internal processes were at play. The idea of an impending supernova became the focal point of discussions. Utilizing the Very Large Telescope, VLT, in Chile, astronomers were able to capture detailed images of Betelgeuse during its dimming phase. These images revealed that the star had developed a distinctively lopsided appearance. Further investigation showed that the dimming was likely due to a massive surface mass ejection, SME, during which Betelgeuse expelled a tremendous amount of material into space. This extraordinary event reshaped the star and disrupted its pulsation cycle. The SME was akin to a volcanic eruption on a cosmic scale, with Betelgeuse releasing 400 billion tons of material, 400 times more than what a typical solar event would produce. This upheaval not only changed the star's appearance but also shortened its pulsation period from 400 days to just 200 days. These dramatic changes indicate that Betelgeuse is becoming increasingly unstable, raising the question: how much longer can it maintain its current state? The recent developments in Betelgeuse's behavior have prompted astronomers to intensify their observations, searching for further signs of its impending collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under the force of gravity, triggering a supernova. This explosion releases an immense amount of energy, ejecting the star's outer layers into space and creating a dazzling light show that could be visible even during the day. If Betelgeuse were to explode, the first sign would be a surge of neutrinos, subatomic particles that travel faster than light and can escape from the star's core. These neutrinos would reach Earth hours before the light of the explosion. Once the light does reach us, Betelgeuse would shine brighter than the full moon, casting shadows and turning night into day for weeks. A supernova of Betelgeuse's magnitude would provide scientists with an unparalleled opportunity to study stellar death in real time. By analyzing the light, heat, and radiation emitted during the explosion, researchers could gain valuable insights into stellar evolution, nuclear physics, and the formation of the elements that make up planets and life itself. To understand Betelgeuse's behavior, scientists are using advanced simulations to model the star's interior. These virtual models incorporate data from telescopes such as the James Webb Space Telescope, JWST, and the VLT, allowing researchers to investigate the processes that drive Betelgeuse's instability. These simulations suggest that a massive gas bubble may have risen from deep within the star, triggering the SME and altering its pulsation rhythm. The JWST has also provided a closer look at the material ejected by Betelgeuse, revealing complex structures of gas and dust surrounding the star. These observations point to the possibility that Betelgeuse may be entering its final stages, offering an unprecedented glimpse into the life cycle of a massive star. While scientists estimate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its erratic behavior suggests that this timeline may be much shorter. The astronomical community is working tirelessly to capture every detail of this cosmic drama before it reaches its dramatic conclusion, ensuring that humanity does not miss this once-in-a-lifetime event. In late 2023, the JWST focused its extraordinary capabilities on Betelgeuse, uncovering a startling phenomenon. Scientists discovered that, already unstable from its massive surface mass ejection, the star had experienced a rapid internal collapse. This collapse was evidenced by significant shifts in the core dynamics, which altered the flow of nuclear fusion reactions within the star. Astronomers observed dramatic fluctuations in Betelgeuse's pulsation cycles. Before the collapse, the star's surface expanded and contracted steadily over 400 days. Afterward, this rhythm abruptly changed to a 200-day cycle, signaling a massive disruption in the star's internal structure. This irregularity is akin to a cosmic heartbeat, suggesting that Betelgeuse is nearing the end of its stellar life. Simulations created by astrophysicists revealed that Betelgeuse's core was becoming increasingly unstable as it fused heavier elements. When stars reach this stage, they begin producing iron, a process that marks the final phase before collapse. Unlike other elements, iron does not release energy when fused, creating a buildup of mass that forces the core toward an inevitable implosion. Betelgeuse's recent behavior has sparked heated debates among astronomers regarding its supernova timeline. While some believe the findings suggest that the explosion could occur within the next few centuries, others argue that it might still be thousands of years away. One thing is clear: Betelgeuse's time as a red supergiant is running out. A key indicator of an imminent supernova is the release of neutrinos, which escape from the star's core just moments before it collapses. Scientists are closely monitoring Betelgeuse for any sudden surge in neutrino activity. Instruments around the world are on high alert, prepared to detect this fleeting signal that could provide humanity with its first real-time warning of a supernova. While Betelgeuse's supernova will undoubtedly be an awe-inspiring celestial event visible even during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting eerie shadows and lighting up the night for weeks. This event will not only captivate stargazers, but also offer an exceptional opportunity for scientific research. The story of Betelgeuse reminds us that the universe is full of mysteries waiting to be unraveled. This colossal star, which has fascinated humanity for centuries, now challenges everything we know about stellar evolution and cosmic dynamics. As Betelgeuse continues to surprise us with its dimming, mass ejections, and unpredictable behavior, it serves as a reminder of how much we still have to learn. Its potential to go supernova offers scientists an unparalleled opportunity to study the life cycle of massive stars in real time. Understanding these processes is not only crucial for unraveling the fate of one star, but also for unlocking the mechanics that shape galaxies, seed the universe with essential elements, and even make life possible. This knowledge enhances our understanding of the universe's history and our place within it. The tools we use to study Betelgeuse, from ground-based observatories like the VLT to cutting-edge instruments like the JWST, have opened windows into the universe that past generations could only dream of. These technologies allow us to create simulations, study the dynamics of stars, and look billions of years into the past, all in an effort to better understand the fabric of reality itself. For scientists like Neil deGrasse Tyson and researchers worldwide, discoveries like these spark a sense of urgency and excitement. They push the boundaries of human knowledge and challenge us to continue exploring the cosmos. The next time you look up at the Orion Belt, remember that one of those points of light holds the story of a star on the edge of its destiny. What do you think will happen to Betelgeuse? Are we witnessing the final moments of a star about to explode? Or is it simply another phase in its mysterious life? Share your thoughts in the comments and join the conversation about one of the most fascinating stars in the universe. Don't forget to like, subscribe, and turn on notifications for more cosmic stories that will blow your mind. Until next time, keep your eyes on the sky. As we continue to observe Betelgeuse, one of the most captivating aspects of the star's behavior is its unpredictability. The fact that such a colossal object, visible to the naked eye from Earth, is undergoing changes so drastic and rapid that scientists are struggling to predict what comes next underscores the complexity of stellar evolution. What makes Betelgeuse especially intriguing is that it is nearing the end of its life cycle, which makes it an invaluable subject for study. In essence, it offers a real-time look at the processes that occur before a star meets its explosive fate, a rare and extraordinary opportunity in the field of astronomy. The latest data coming from various telescopes has opened new avenues of exploration. As scientists continue to probe the details of Betelgeuse's behavior, they are uncovering intricate details of its structure that were previously hidden from view. These details are critical in understanding how massive stars undergo their final transformation. For example, astronomers have now pinpointed that the star's core is slowly becoming more unstable, signaling that it may soon begin the process of fusion that will lead to the creation of heavier elements like iron. The production of iron within the star is a key indicator that Betelgeuse is approaching its final moments, as this process is unable to sustain the core's energy requirements, triggering the star's collapse. The concept of a supernova is itself awe-inspiring. It represents one of the most powerful and spectacular events in the universe, releasing vast amounts of energy, much of it in the form of light, heat, and radiation. For the first time in history, humanity will have the chance to study such an event in detail, potentially gaining insights that could change our understanding of the universe itself. The intensity of the explosion, combined with the amount of radiation and the vast quantities of elements created and expelled into space, has the potential to alter our understanding of everything from the life cycle of stars to the very creation of elements that make up planets, and possibly even life. By closely examining the details of Betelgeuse's eventual explosion, scientists could discover new ways to study stellar phenomena in unprecedented detail. In addition to understanding stellar evolution, Betelgeuse's supernova may also have broader implications for fields like nuclear physics. The precise way in which heavy elements are created during a supernova could provide a much-needed glimpse into processes that have been theorized but never fully understood. The enormous amounts of energy released during the collapse of Betelgeuse's core will offer valuable data for understanding the forces at play during stellar collapse and the behavior of atomic nuclei under extreme conditions. In many ways, Betelgeuse's impending fate also holds deep philosophical significance. It forces us to confront the fleeting nature of stars, and by extension, the impermanence of all things in the universe. While we may not be alive to witness Betelgeuse's actual explosion, since the event may not occur for tens of thousands of years, the study of its final stages gives us a unique and rare perspective on the life cycle of stars. This information will remain crucial for generations to come, helping us understand the very nature of our universe, from its birth to its inevitable decay. Looking beyond Betelgeuse, the lessons gleaned from this extraordinary star will also influence our understanding of other stars, including our own Sunday. While our sun is not massive enough to end its life in a supernova, the processes that govern stellar evolution apply universally, and studying a massive star like Betelgeuse can provide clues about the eventual fate of all stars. In the distant future, we may come to understand more about the vast distances between stars, the processes that govern their formation, and the intricate ways that stars influence their surrounding environments. Whether or not we ever get to witness Betelgeuse's explosion firsthand, its story will be crucial in shaping our broader understanding of the cosmos. As the scientific community pushes the limits of current technology to observe and analyze Betelgeuse, new breakthroughs in telescope technology, computational simulations, and data analysis are continually transforming our approach to stellar research. With each advancement, scientists are inching closer to understanding how the universe operates on its most fundamental level. These advances not only help us unlock the mysteries of individual stars, but also contribute to our overall knowledge of galactic evolution and the broader cosmic narrative. The quest for answers about Betelgeuse is part of a larger movement within the scientific community to explore the unknown and answer the most profound questions about our existence. What is the fate of the stars? What is the ultimate destiny of the elements that make up everything around us? How do the building blocks of life come together to form the galaxies, stars, and planets that we see in the night sky? The search for answers to these questions is one of the driving forces behind much of the current astronomical research, with Betelgeuse serving as an essential case study.